Okay, I'm going to work through the solution for problem number 3 for the final exam for fall 2010. And for the problems 1 through 3, it states let function f of x equal to 2 divided by e to the negative x plus 1 for all x less than 0. Let f of x equal to the square root of x plus 1 for x between 0 and 3. And let f of x is equal to x plus 2 divided by x squared plus 1 for x greater than 3. And looking at these constraints, we can define our intervals. This one would be from negative infinity to 0. This interval would be from 0 to 3. And then this interval would be from 3 to infinity. Okay, and problem number 3 actually states what is the limit as x approaches infinity of f of x. And so we need to evaluate the limit of f of x, but in order to do that, we need to know which part of this compound function or complex function that we need to use. And so we're trying to look at the function as x approaches infinity. So we're actually going to be in this interval here from 3 to infinity. We're actually going to be on the higher side of the interval. So we want to rewrite our limit now as x approaches positive infinity of x plus 2 over x squared plus 1. Okay, so there's 2 ways to approach this. I'm going to actually go through both of the ways. So this will be the first way. So this would be way number 1. Okay, and basically, since we're evaluating a limit as x approaches infinity, this is the concept of limits, infinite limits. And so what we do is we can divide both the numerator and the denominator by the highest power of x in the denominator. So in this particular problem, that's actually going to be x squared. So we can rewrite this limit as x approaches positive infinity. And we're going to divide the numerator by x squared, which is just x divided by x squared plus 2 divided by x squared, and divide the denominator by x squared, so we get x squared over x squared plus 1 over x squared. And so we see that if we simplify this, limit as x approaches positive infinity, on the numerator, this x will cancel out, and we have one of the squares cancel out, so we'll just get 1 over x. And the limit as x approaches infinity of 2 over x squared, if we put infinity over here, that would just be 2 over 0, or 2 over infinity. So we can just put, we'll just leave it as 2 over x squared for now, everything in terms of x's. And in the denominator, you see that that's just 1 plus 1 over x squared. Okay, so we can go ahead and evaluate this limit now by direct substitution. So we can say the limit as x approaches positive infinity of 1 over infinity plus 2 over infinity squared over 1 plus 1 over infinity squared. So that's just directly substituting in positive infinity in for x. And when we do that, we can get the limit as x approaches positive infinity, and the limit of 1 over infinity is just 0, so we get 0 over the top. So we get 0, and 2 over infinity would just be 0 plus 0 over 1 plus 0 which is 0 over 1, which is 0. Okay, so that's actually the answer, and that's using the approach where we divide the numerator and the denominator by the highest power of x, or the variable in the denominator. And when we do that, we get an answer of 0. So now we can do it the second way. I'm going to erase this. The second way, we're still going to have the same limit, where we have the limit as x approaches positive infinity of x plus 2 over x squared plus 1. So we still have the same limit, but now if we go ahead and directly substitute in infinity, we get the limit as x approaches positive infinity of infinity plus 2 over infinity squared plus 1. And we see that we get the limit as x approaches positive infinity. The numerator just works out to be infinity. The denominator just works out to be infinity. Even though we have an infinity squared, it's still infinity. So we have the limit of infinity over infinity. And you might recognize this as indeterminate form. And so since we have an indeterminate form of infinity over infinity, that allows us to use L'Hopital's rule. And basically that says if we get the limit as x approaches some number a of f of x over g of x is equal to infinity over infinity, then we can rewrite the limit as x approaches a of the derivative of f divided by the derivative of g. And so really all we have to do is define f and g, which is the numerator and the denominator, and then take the derivative. Okay, so if we define f to f of x is equal to x plus 2, and g of x is equal to x squared plus 1, then the derivative of f is equal to 1, and the derivative of g is equal to 2x. So now, applying L'Hopital's rule, we can say the limit as x approaches a, in this particular case it's infinity, of the derivative of f, which is 1, over the derivative of g, which is 2x. Okay? So here's our rewritten limit, right there. And if we want to evaluate this, we can say that's the limit as x approaches infinity of direct substitution. We put infinity in for x, and we get 1 divided by infinity, which is the limit over 1 over infinity, is actually 0. So this is the second approach to this problem where we're using L'Hopital's rule, because we saw when we used direct substitution we got an indeterminate form of infinity over infinity. And when we did that, we got the same answer as 0. So you can do it either of one or two ways. It's your choice, whichever you're more comfortable with.